So this is GCSE Foundation Angles exam questions coming from the November induction booklet. These are solutions for the first parts of the questions. So question 1, shown below are the measurements of the type of angle. So we want to identify which angle matches up to which name. So 180 degrees, hopefully you recognise straight away as being a straight line. 79 degrees is less than 90 degrees, so it's an acute angle. 90 degrees is a special type of angle, that's a right angle. We then have 198 degrees, that is what we call a reflex angle. And then finally 94 degrees is what we call an obtuse angle. So a reflex angle is between 180 to 360 degrees. Acute angle is from 0 to 90 degrees. Straight line is just 180 degrees. Right angle is 190 degrees, and obtuse angle is between 90 to 180 degrees. Okay. Question 2, we want to measure this angle. Okay, so let's get a protractor out. And here is our protractor. So if we move this, when you move this, you see this crosshair here, this bit here. You need to make sure that is right at the corner of the angle. So it reads like this. So you can now see that that crosshair is on the angle. The other important thing to do is to make sure that the 0 line of your protractor is along at least one of these. It doesn't matter which one, but at least one of these, so that you can then read the angle. Now, there are 2 angles on this, and so which one should you use? Well, because we're going in this direction, we should be using the outside, so it's reading in the clockwise direction. So it's from starting from 0, 0 is on the outside one, and if we count up, we should get an answer here of 26 degrees. Okay, next question. So here is a trapezium. We want to mark a right angle with a letter R. So there are a couple here. I could mark this as a right angle, or I could mark this as a right angle. Please make sure you actually mark the angle itself. It says here, part B, mark an acute angle with a letter A. So there is only one acute angle on here. There's an angle here. Now it's got to be clear again, mark which one you're on. If you just put an A here, this could mean this outside angle here, or it could mean this inside angle here. So actually mark with a curve the angle you're referring to. And then mark an obtuse angle with the letter O. Again, if we was to mark up here, there is an obtuse angle here, but there are 2 angles, one's reflex and one's obtuse. So just make sure you're clear by marking it with a curve which one you are indicating to be an obtuse angle. Okay, next question. So in the space below, we want to draw an angle of 80 degrees at A. That means that the angle has to be at this end of the line, not in the middle, not at this end here. It has to be at this end of the line. So again, we're going to need a protractor. Here's our protractor. We're going to put this crosshair. The crosshair is going to go at the end of the line where A is. So there you go. Here's our crosshair. It's on the end of the line where A is. Now this time, if you notice, the outside track is 180 degrees. So we want to measure on this inside track here. Okay, so counting up 10, let's get the pen working now. So there's 10, 20, 30, 40, 50, 60, 70, 80. So marking here at the 80 point, that is our angle of 80 degrees. And at this point, using a ruler, so hopefully using a ruler, what you should be able to do is if I move this around, should be able to now turn this. Let's get this ruler lined up so it's on this point here, and then turn it round. So use a ruler. Here we go. Just going to turn a little bit more. There we go. There's my line of 80 degrees. So use a ruler just to connect it up. And here I now have. I'll have to move this down a bit because it won't let me draw. Not perfect, but there we have our straight line. And that there, make sure you mark with the 80 degrees. Okay, moving on. In this question, we want to work out the size of the angle marked y. So please note that this is a right angle, this is 90 degrees. All these angles around the point should add up to 360. So if we do 360 minus 110 minus 90, that should give us the angle that's left over for y, which is 160 degrees. Answer you have to give must be a full sentence, so we have to say something that makes sense, such as angles around a point add to 360 degrees. Okay. Now, if you don't write a sentence that makes sense, you will not get a mark. So just write down 360 degrees or point equals 360 degrees. Doesn't make sense. You need to state angles around a point add up to 360 degrees. Let's look at our next question. This is part B. Work out the angle, size of angle marked W. So that's this angle here. And then we want to give a reason for the answer. So notice here we're talking about a straight line. We know that angles on a straight line add up to 180 degrees. So we're going to do 180. Let's make that clear. Sorry, excuse my handwriting. 180 minus 121, and that should give you an answer of 59 degrees. And again, you have to write full sentence, angles on a straight line add to 180 degrees. Writing a straight line equals 180 degrees, anything like that doesn't make sense. You have to say angles on a straight line add to 180 degrees. Okay, so question 6, work out the size of x. Now what I've got here is I've got three angles. And so I know if I add them up, x plus x plus x, I know because they're on a straight line they add up to 180. Well, if I add up x plus x plus x, I get 3x equals to 180. So what I know now is if I want to find what 1x is worth, I'm going to divide by 3, and 180 divided by 3 is 60 degrees. Okay, so get marked there for if you've written some sort of equation. Either of these two equations here is fine, and then another mark if you've got 60 degrees. Moving on. So here we have a quadrilateral. We're asked to work out the size of the angle marked x. Note down that this is a right angle, so it's 90 degrees. What we must know for a quadrilateral is that angles in a quadrilateral add up to 360. So again, if we're looking to find that missing angle, what I'm going to do is I'm going to subtract the angles I know. So the 90, 101 and 53, I'm going to subtract them all away from 360. Now you can either add up the three angles and subtract them from 360, or you can just subtract them like I have done in this sum here. Either way will give you the correct answer, and you should get an answer of 116 degrees. Okay, so let's move on then. Work out the size of angle x. Well, here we have a triangle. We should know that the angles in a triangle add up to 180. So I'm going to subtract the angles that I know from 180. Again, you can add the two angles up that you know if you want, and then subtract it from 180. It doesn't matter, both will give you the same answer. They both should give you an answer of 46 degrees. Okay, so moving on to the next question. Work out the size of angle A. Well, you should be able to use the property that vertically opposite angles are equal. But if we work out angle B first of all, and then you'll see why that's true. So angle B, this angle here, notice it's on a straight line. If I was to cover up and ignore this line here, I'll just quickly do it with a red pen and then I'll remove it. This angle here, all the way around here, that adds up to 180 degrees. So I don't need to use the angles around a point because I know that actually on this straight line they add up to 180 degrees. And so all I have to do is say 180 minus 104 equals 76 degrees. So I know B is 76 degrees. So let's have a look to see why vertically opposite angles are equal. If I go back to using a red pen just to highlight this a second, if we look at this straight line here, I know that these two here add up to 180 degrees. So then I know this one here must also be 76 degrees, which is the same as the one that is vertically opposite. And that means if I remove, if I was to, let's get rid of this one here a second. That means if I was to look at either, and we can use either of these ones here. I could look at either this straight line here, or I could look at this straight line here. Both of them have an angle of 76, and the other one has got to pair up to make 180 degrees. And so the only way that works is if this angle here is 104 degrees. And if you add them all up again, you'll find it comes to 360. Okay, so just remember, we have got two straight lines, angles that are vertically opposite, they are equal. Okay, so let's move on. Here we have a parallelogram. In a parallelogram, it's important to know that these two sides here are parallel, and we use one arrow to indicate they're parallel, and they are also the same length. These two sides here are also parallel, and we use two arrows this time to indicate it because they are parallel, but they are of a different length, in a different direction. And actually these two sides are the same length. And what you'll find is these two angles here are equal. So the angle Y is in fact 64 degrees. That means if those two angles are equal, similarly these two angles here are equal. Now if I want to find angle X, what we do is I can use angles in a quadrilateral add up to 360. So if I was to do 360 minus 64, I know this one's 64 as well, so I'm going to take away 64 twice. That gives me 232 degrees. And what I know is that's for two angles there, so X will be equal to 232 divided by 2, which is 116. Now there's an important property of parallelograms, and that is that if you notice, let's do this in green, it's a slightly different colour, these two angles here, sorry that's not 106, let's make that clear, should be 116. These two angles here, which I've highlighted, add up to 180 degrees. And in fact, all the pairs of angles add up to 180 degrees. So it's another property there of a parallelogram. Okay, so let's move on. Here we have three straight lines. We want to find the size of angle Y. Okay, this is a typical example of a GCSE question, certainly the later questions in a paper. Now, what my advice is on these questions is, if you can't find the angle that you need straight away, go through finding angles that you can find. So, for example, if I start off here, I can actually find this angle here. It's not the angle I want, but I can find it. It's an angle on a straight line, so I'm going to do 180 minus 151, which gives me an answer of 29 degrees. Now, I've got two angles in this triangle. So I can now find this angle here, because I know that the three angles in a triangle add up to 180, so I can subtract the angles I know, which are 180 and 29, which are 29 and 93. And if I subtract those two angles from 180, what we get is an answer of 58 degrees. So this angle here is 58. And now I've got this angle and it's on a straight line, I can now find Y. So Y is equal to 180 minus 58, which gives us an answer of 122 degrees. So many angles questions are like this, certainly the tougher ones at the end of a paper, where actually it's not clear how you're going to find the missing angle itself, and what you're going to have to do is you're just going to have to find any possible missing angles. Other missing angles I could have found here, I could have found this was 93, I could have found that this is 87, this is 87, but they wouldn't have been much help. If you find them, I mean, same for these ones here, if you find the pairs, etc., it's not going to harm you, but just keep on going, keep on finding all the angles you can, and eventually, at some point, you will get to the angle that they're looking for. Okay, so one other question. Here we have a triangle. In fact, we have three triangles because I've got triangle DCF, this big one here. I've also got this triangle CEF, and I've also got this triangle CDE. So there's three triangles here. Okay. Notice that we've got these two lines here. This means that the triangle CEF is an isosceles triangle, and that means these two angles here are equal. Okay, and that's going to become important in our solution. So again, it says to find the angle marked y, and the only way you can approach this is just find angles that you can find. Okay, now if I know that this is a isosceles triangle, what I know is then that these remaining angles, the 2x, that's going to be equal to 180 minus the 40 degrees at the top of the triangle. So those two angles must add up to 140 degrees. And so if I want to find one of those angles, I divide it by 2, and I get each of these angles is now equal to 70 degrees. Now there's a couple of ways that I can find this angle here. That's either using triangle CDF or by just using a triangle CDE. What I can do, I'll just use CDE. This angle here, if I know this is 70, this is going to be 180 minus 70, which equals 110. So then finally, the angle y, I know is another one in a triangle, so it's going to be 180. I'm going to take away this 15 degrees. I'm going to take away the 110 that I've just found. And so we get an answer of 55 degrees. And in fact, if you check, if you use the triangle CDF, so using CDF, what we get is the angles in a triangle are 180, take away the 70 at F, and then we're going to take away this 55 degrees at C, and it still equals 55 degrees. Okay, and so it's come out as the same answer. So the angle Y is 55 degrees. These questions are a little bit tougher, but just persist. Remember that 4 marks here, you're going to get method marks, a couple of marks perhaps for finding 70 degrees, a mark over here. You're going to get marks for finding some of these missing angles. So even if you can't find the final angle, you should get marks for finding other angles in the triangle. Okay, well I hope all those solutions made sense and you was able to follow them.